Hello and welcome everyone to yet another tech enthusiastic video from Edureka. Today, we will learn about Apache Hive. Now, let's quickly begin with our session for today. Apache Hive is one of the best open source software utilities which has SQL-like interface that is used in data querying and data analytics. Today, we will discuss more about Hadoop through the following agenda. Firstly, we shall understand why exactly we needed Apache Hive. Followed by that, we shall understand what is Apache Hive, then its important features. Then comes the important stage where we will understand the Apache Hive architecture, the components involved in Apache Hive. Then we will learn how to install Apache Hive in Windows operating system. Followed by that, we shall understand the data types, operators, data models which are present in Hive. Then we shall go through a brief demo of Apache Hive. So let's quickly begin with the first topic, that is why exactly we needed Apache Hive. It all began in the early 90s when Facebook started. Slowly, the number of users at Facebook increased, that is, nearly 1 billion users, and along with the users increased the data, which is nearly equals to thousands of terabytes of data and nearly 1 lakh queries, then also 500 million photographs uploaded daily. And this was a huge amount of data that Facebook had to process. And the first thing that everybody had in their mind was to use RDBMS. And we all know that RDBMS couldn't handle such a huge amount of data, and neither it was capable enough to process it. And the very next big guy who was capable enough to handle all this big data was Hadoop. Even when Hadoop came into picture, it was not too easy to manage all the queries. It used to take a lot of time to execute all the queries performed. So one common thing that all the Hadoop developers had was the SQL. So they thought to come up with a new solution that has Hadoop's capacity and interface like SQL. That is when Hive came into picture. So now we understand the exact definition of Apache Hive. Apache Hive is a data warehouse software project built on top of Apache Hadoop for providing data query and data analysis. Hive gives a SQL-like interface to query data stored in various databases and file systems that integrate with Hadoop. Also, Apache Hive has data warehousing software utility. It can be used for data analytics. It is built for SQL users, manages querying of structured data, and it simplifies and abstracts the load that is on Hadoop. And lastly, no need to learn Java and Hadoop API to handle data using Hive. So followed by this, we shall understand Apache Hive applications. Apache Hive is used in many major applications. Few of the major applications are as follows. Hive is a data warehousing infrastructure for Hadoop. The primary responsibility of Hive is to provide data summarization, query, and data analysis. It supports analysis of large datasets in Hadoop's HDFS as well as on Amazon S3 file system. Followed by that, we have document indexing with Hive. The goal of Hive indexing is to improve the speed of query lookup on certain columns of a table. Without an index, queries could load an entire table or partition a whole process as rows. This would be troublesome. So, with Hive, we have solved this problem. Followed by that, predictive modeling. The data manager allows you to prepare your data so it can be processed in automated analytics. It offers a variety of preparation functionalities, including the creation of analytical records and timestamp populations. Followed by that, the next important application of Hive is business intelligence. Hive is a data warehousing component of Hadoop, and it functions well with structured data, enabling ad hoc queries against large transactional datasets. Hence, it happens to be a best-in-class tool available for business intelligence and helps many companies to predict their business requirements with high accuracy. Last but not the least, log processing. Apache Hive is a data warehouse infrastructure built on top of Hadoop. It allows processing of data with SQL-like queries and is very pluggable so that we can configure it to provide our logs quite easily. So these were the few important Hive applications. Now let us move ahead and understand Apache Hive features. The first and the foremost important feature of Apache Hive is SQL type queries. The SQL type queries present on Hive will help many of the Hadoop developers to write queries with ease. Followed by that, the next important feature of Apache Hive is OLAP based design. OLAP is nothing but online analytical processing. This allows users to analyze database information from multiple database systems at one time. So using Apache Hive, we can achieve OLAP with higher accuracy. Followed by the second feature, we have the third feature which says Apache Hive is really fast. Since we have SQL-like interface in Apache Hive, using this feature on HDFS will help us writing queries faster and executing them. Followed by that, we believe Apache Hive is highly scalable. Hive tables are defined directly in Hadoop file system. Hence, Hive is fast and scalable and easy to learn. Followed by that, it is known to be highly extensible. Apache Hive uses Hadoop file system, and Hadoop file systems or HDFS provides horizontal extensibility. And finally, the ad hoc querying. Using Hive, we can execute ad hoc querying to analyze and predict data. So these were the few important features of Apache Hive. Let us move on to our next topic, where we deal with Apache Hive architecture. The following architecture explains the flow of submission of query into Hive. The first stage is the Hive client. Hive allows writing applications in various languages including Java, Python, and C++. It supports different types of clients such as Thrift Server, JDBC driver, and ODBC driver. So what exactly is Thrift Server? It is a cross-language service provider platform that serves the requests from all these programming languages that supports Thrift. Followed by that, JDBC driver. It is used to establish connection between Hive and Java applications. The JDBC driver is present in the class org.apache.hadoop.hive.jdbc.hive driver. Finally, we come to ODBC driver. So what exactly is ODBC driver? ODBC driver allows the applications that support ODBC protocol to connect to Hive. Followed by that, we have the Hive services. The following are the services provided by Hive. They are Hive CLI, Hive Web User Interface, Hive Metastore, Hive Server, Hive Driver, Hive Compiler, and lastly, the Hive Execution Engine. The Hive CLI or Command Line Interface is a shell where we can execute the Hive queries and commands. Followed by that, the Hive Web UI is just an alternative for Hive CLI. It provides a web-based graphical user interface for executing Hive queries and commands. Followed by that, the Hive Metastore. It is a central repository that stores all the structured information of various tables and partitions in the warehouse. It also includes metadata of column and its type information, the serializers and deserializers, which is used to read and write data, and the corresponding HDFS files where the data is stored. Followed by that, the Hive server. It is referred to as Apache Thrift Server. It accepts the requests from different clients and provides to the Hive driver. Moving on, we shall deal with Hive driver. The Hive driver receives queries from different sources such as Web UI, CLI, Thrift, and JDBC or ODBC drivers. It transfers the queries to the compiler. Followed by that, we have the Hive compiler. The purpose of Hive compiler is to parse the query and perform semantic analysis on the different query blocks and expressions. It converts HiveQL statements into MapReduce jobs. Finally, we have Hive Execution Engine. Hive Execution Engine is the optimizer that generates the logical plan in the form of DAG or directed acyclic graph of MapReduce tasks and HDFS tasks. In the end, the execution engine executes the incoming task in the order of their dependencies. Followed by that, we have the MapReduce and HDFS. MapReduce is the processing layer which executes the mapping and reducing jobs on the data provided. Lastly, the HDFS or Hadoop Distributed File System is the location where the data which we provide is stored. So this is the architecture of Apache Hive. Then moving next, we have Apache Hive components. So what are the different components which are present in Hive? They are, first one, the shell. Shell is the place where we write our queries and execute them. Followed by that, we have Metastore. As discussed in the architecture, the Metastore is a place where all the details related to our tables is stored, like schema, etc. Followed by that, we have the execution engine. So execution engine is the component of Apache Hive which converts the query or the code which we have written into the language which the Hive can understand. Followed by that, driver is the component which executes the code or query in the form of acyclic graphs. And lastly, the compiler. Compiler compiles whatever the code we write and executes and provides us the output. So these are the major Hive components. Moving ahead, we shall understand Apache Hive installation on Windows operating system. So Edureka is all about providing the technical knowledge in the simplest way as possible and later play around with the technologies to understand the complicated parts of it. So now let's try to install Hive into our local system in the most simplest way as possible. To do so, we might need the Oracle VirtualBox which looks like this. So once after you download Oracle VirtualBox and install it into your local system, the next step would be to download the Cloudera Quick Start VM for your local system. The link to this will be provided in the description box below. Now let's quickly start our Cloudera Quick Start VM with our Oracle VirtualBox. Select import option and now provide the location where your Cloudera Quick Start VM is existing. In my local system, it is in the local disk drive F. There you go. Select open and now just make sure your RAM size is more than 8 GB. Just randomly I'm providing 9000 MB which is just above 8 GB so that you have a smooth functionality of Cloudera. Now select import and there you go. You can see that Cloudera Quick Start VM is getting imported. Now you can see that Cloudera Quick Start VM has been successfully imported and it's ready for deployment. You can just double click on it and it'll get started. You can see that Cloudera VM has been successfully imported and it started. And also you can see that we have gone live on Cloudera. You can see all the Hue, Hadoop, HBase, Impala, Spark, which are pre-installed in Cloudera. Now our concern would be to start up Hive. So to start Hive, you need to start up Hue first. So let me remind you one thing. In Cloudera, every single password and username is Cloudera by default. So for example, we have got Hue username and password here. So the username, that is the default username for Cloudera's Hue would be Cloudera. And along with that, even the password will be Cloudera. That is by default. So we have got Cloudera and Cloudera as username and password respectively. Let's just sign in. You may select remember option in case if you forget your passwords. So now we are getting connected to Hue and we are live on Hue now. There you go. We've got started our Hue. So now we'll enter into HDFS. There we go. We have our Hive here. Now that we have successfully installed Hive into our local system, let us move further and understand a few more concepts in Hadoop. Firstly, we shall deal with the data types. The data types are completely similar to any other programming language which we have. They are tiny int, small int, integer, big int. Similarly, followed by that we have float. And inside Hive, float is used for single precision. And if you want double precision, you can go ahead with double. And followed by that we have a string and boolean, which are completely similar to any other programming languages which we use in this daily life. Followed by that we have Hive data models. So these are the basic data models which we use in Hive, that we basically create databases and store our data in the form of tables. And sometimes we also need partitions. We will discuss each one of these data models in our demo ahead. So we'll first create databases, and inside databases we will be creating tables inside which we will be storing data in the form of rows and columns, and along with that partitions. Partitions, they are like advanced way of storing data. Like if you have, just imagine you're in a school, say standard 1, and inside standard 1 you have sections A, B, C, D. So partition is like you're getting partitions for section A, section B, section C, and section D. You're storing different students in different sections, so that when you're querying for a particular data, for example, say you're searching for a kid called Sam, and you have the section of his class as B. So you just don't have to just search for Sam in all the 4 sections. You can just directly go into section B and call in Sam, and you'll get access to him. That's how partitions work. Followed by partitions, we have buckets. So similar to partitions, even buckets work in the same way. Let's understand each one of these in much better way through a practical demo. After data models, we shall understand about Hive operators. So what are operators? Operators are any other operators that we use in normal programming languages, such as arithmetic operators, logical operators. We shall also go through some examples based on arithmetic and logical operators in Hive in the Hive demo. We will use some arithmetic operations as well as logical operations on the data which we have stored in the form of tables in Hive. We shall go through a brief look on that as well. So before we get started, let's have a brief look on the CSV files that I have created for today's demo. These are the small CSV files that I've personally created using MS Excel, and I've saved them as .csv files. I've made the CSV files to be smaller because just to make sure the execution time consumed is as less as possible. Since we're using Cloudera, the execution time might be a little more. So it's better if we use smaller CSV files. So this is my first CSV file, which is employee.csv, which has employee IDs, employee name, salary, and age. Similarly, we have another employee2.csv file, which has the same details along with one more column, that is the country column. I've included country because we will be using this country column in joins that we will be performing in future. Followed by that, we have the department. So here we have department ID and department name. So we have development department, testing, product, relationship, admin, and IT support. Similarly, we also have student CSV. This is another CSV file that I have created. This has ID, name, course, and age of the student. Followed by that, we have another CSV. This is student report.csv, which has the reports of a particular student, gender, ethnicity, parental education, lunch, course, math score, reading score, writing score, and other. So these are the CSV files that we will be using in our demo today. So now let's quickly begin with our demo. So to start Hive, we shall open a terminal. So starting or firing up Hive in Cloudera is really simple. You just have to type in Hive and enter. There you go. Logging initialized using configuration files and etc. The Hive CLI is deprecated and migration to Beeline is recommended. And there you go. Your Hive terminal or CLI has been started. So first, let's try to create a database. To save time, I've already created the document which has all the codes that we will be executing today. So this is the particular file which I will be using today. So don't worry, this file will be linked in the description box below. You can use the same file and try executing the same codes in your personal systems just for practice if you feel so. So just to save time, I've already created the document which has the codes that we are going to execute today. So this code or this file will be attached in the description box below. You can get access to it, and you can also execute the same codes in your own personal system to have a practical experience about this particular Hive tutorial. So the first thing that we will be doing today is to create a database. So I'm going to create the database using SQL type commands, which are create database, name of the database, which is Edureka. There you go. The database has been successfully created. So now you can also use the following command to check if your database has been created or not. So show databases will help you to find it. So there you go. You can see the first database, which is a default database, which will be pre-existing. And followed by that, you have our own database, which we have created now, that is Edureka. So followed by this, next we will move ahead and try to create a new table. So when you come into tables, you need to understand there are two types of tables in Hive. They are managed tables or internal tables, followed by that external tables. So what is the difference between these two tables? So internal table or managed table is the default table that will be created whenever you try to create a table in Hive. So for example, if you're trying to create a new table, say Edureka, then Hive considers that particular table as an internal table by default. So when you create an internal table, your data is not secured. Understand this. So when you create an internal table, your data is not secured. In case, just imagine you are working with a team and all your team members have access to your Hive or Hue. So the table has been existing in your Hive, and some random newbie or some random inexperienced guy tries to change few things in your table, and accidentally he ends up deleting the table. So when you delete the table, then if the table was created using an internal table code, then your data will be erased. So that's the disadvantage of using internal tables. But in case if you create an external table, even if somebody tries to delete your table, the table or the data, whatever is there, will be deleted from their own local system, but not from Hive. So that's the best part of using external tables. Don't worry, we will discuss about internal tables and external tables as well. So first we'll try to create an internal table. So this particular code is based on internal tables. So we are using SQL type command here, which is create table, and the table name is employee, and the columns inside our table are ID of the employee, name of the employee, salary, and age. So row format has been delimited, followed by that, since this is a CSV file, so the fields will be terminated by comma. And don't forget, you have to use semicolon. Unless you use semicolon, your code is not complete. So let's fire and enter and see if the table gets created or not. Yeah, the table is created successfully. Now we shall see the table, or let's describe the table. So describing the table means you can see what are the columns which are present in your table. So to describe a table, you can use the keyword describe and name of the table, which is employee. And don't forget semicolon. There you go. So your table has the columns ID, name, salary, age. So those are the 4 columns which you have included in your particular table employee. Now let's move ahead and see if this particular table is an internal table or managed table, or the other type of table, which is the external table. So to do that, we can just write in describe formatted table name and semicolon. There might be a small issue here. Yeah, there is a typing mistake. That is describe. I missed S. So there you go. We got it. So this particular table is managed table, as you can see here. Now let's move ahead and try out external tables. Let's clear our screen first. You can use Ctrl+L to clear your screen. There you go. We have a clear screen now. Now let's try to create an external table. Creating an external table is completely similar to that of internal table, but the only difference is that you need to add in a keyword which is external. So this particular keyword is used to create an external table. Now let's fire and enter and see if the table gets created or not. You can see the table got created. Now let's try to describe the table, employee 2. Don't forget the semicolon. I'm saying this again and again because most of the times we miss semicolon and we will get an error. So you can see the table got described and we have the following columns inside our table. Now let's move ahead and see if this particular table is an external table or a managed table. To do so, you can type in describe formatted, the same code what we have used earlier, that is describe formatted, name of the table, that is employee 2, semicolon. Don't forget, there is some issue again. I think I've missed something, or maybe a typing error. Yeah, this is a typing error. Yeah, there you go. The table type is external table. So that's how we create an internal table or managed table and external table. So now that we have understood how to create a database and table, and the 2 types of tables, that are internal table or managed table, followed by that the second type of table, that is the external table. Now let's try to create an external table in a particular location. So for that, you can use the following code, but the only difference is you are specifying the location, that is user Cloudera Edureka employee. EDUEMP is a file that we will be creating in our Hive. So let's fire and enter and see it if it's created or not. Yeah, it's successfully created. Let's go back to Hue and see if the following table is created or not. So one thing you have to remember is when you fire in a command, or if you try to create a table, the first folder that will be created is a warehouse. So inside Hive, you have your warehouse, and inside warehouse, you have all the databases that we have created. Our first database was the Edureka database, and after that we have created table which is employee, and the second table is employee 2. So this is in the particular location which is user Cloudera, and the file is employee 2. Let's see that. This was the file. Yeah, sometimes Hue will not show it because of network issues. You don't have to worry about it. You will get back that data. Now, followed by this, let us enter into Hue again. So when you come back into Hue, if you have to upload a file into Hue, you can just select this particular option, which is plus. So selecting this will give you a dialog box, which will be something like this. And here you can just select any of the files which you want to upload into Hue. Now let me select a student report.csv and select open. So there you go, upload is in progress. So the data file has been successfully uploaded. Now if you want to access your data file, you can just click on that. So there you go, you have all your data successfully loaded onto Hue. You can also perform queries on this particular data. You can just select query, and inside that you just need to select editor, and you have various editors over here, which is Pig, Impala, Java, Spark, MapReduce, Shell, Scoop, and we also have Hive in here. So if you just select Hive, and there you go, you have the editor here. You can just type in your commands or queries, whatever you have. So you have many dictionaries as well. You can just select any one of those, select, and that's how you write queries on the Hive terminal. Now let's not waste much time here, and we have a lot to learn. So let's continue with the next topics in our today's session. Now we shall try to edit the tables. Now we have created the new table, that is employee 3, and we have named the columns as ID, name, string, salary, age, and float. Now we shall try to make some alterations to our table. So the first alteration that we will try to make to our table is to rename our table as EMP table. You know that our employee table was named as employee 3. Now we are trying to rename it to EMP table. So we are using the keyword alter here. So just fire an enter and see if this is possible or not. Yeah, it is possible. The name has been changed to EMP table. Now let's try if it's completely changed or clearly changed or not. You can just type in describe EMP table semicolon. If we get the same column names in our description, then it should be changed. So there you go. We can see the same columns here. So we have successfully changed the name to EMP table. Now we shall also try to add in some more columns to our table, which is EMP table. So here we'll try to add in a new column, that is the surname of string data type. So I'm doing that by using the keyword alter followed by that table. The table name is EMP table, and I'm using the keyword add columns, and the column name is surname, and the data type of that column is string. So now let's fire and enter, and there you go. We have successfully added a new row to our table. Now let's try to describe our table again and see if the column has been successfully added or not. There you go. You can see the last row, which is the surname that we have added most recently. So this is how you can alter the table, and you can also change the names of the existing columns. Let's try to do that one as well. Now what I'm doing is I'm changing the column name to first name. So one of the column name in my table EMP table is the name, which gives me the names of the employees. So since I added surname, I'll change this column name from name to first name. So this is the command that I'm using for that operation right now. Let's fire and enter and see the result. Yeah, the change has been made. Let's describe our table. Don't forget the semicolon. There you go. You can see that earlier we had name. Now it's been changed to first name, and we also have a surname. Let's clear our screen. So that's all for alterations. Now we shall move ahead into our next major topic, or the data model, which is partitioning. So we have dealt with the first two data models, that are databases and tables. So we have learned how to create a database, and we have learned how to create a table. We have learned how to create internal or managed table, and also we have created external table, and also we have learned how to create an external table in a particular location in your Hive and load data to your table, and also how to alterate your tables, the column names, the name of your table, and how to add or delete new columns to your table. So far so good, and now we shall continue with the next type of data model, that is the partitioning. As we have discussed earlier about partitioning, it's completely similar to a school or a college. Just imagine that you are in a college, and you are in computer science section. So a college has many branches. So maybe computer science, mechanical, and electronics and communications. So imagine your name is Harry. So if someone comes to your college and if he's looking for Harry, so there are many Harrys in your school. So if the person is asking specifically about you, that is Harry from computer science, then can you imagine how simple is this query? So you don't have to search for electronics and mechanical. You just have to come into the class computer science and search for Harry, and there you go, you're present. So that's how partitions work. To execute commands or to execute queries on partition, we will create a whole new database here. Let's start everything from fresh. So we'll create a separate database for executing our new data model, that is partitioning. So I'm creating a new database, that is Edureka student. So there you go. The database has been successfully created. Followed by that, let's use this database now. To use the database, you just need to add in the keyword use and name of the database. So let's fire and enter, and now we are currently using Edureka student database. Now let's create a table in Edureka student database. So here I'm creating a normal table, that is the managed table. So inside my student table, I'll be having some basic columns such as ID number of the student, name of the student, what is his age, and course. So you're not finding course here because I'm going to partition the table based on course. So here you can find the course. I'm using the keyword partition, and on what terms? So on the terms of course, I'm going to partition students. So we have discussed about our students CSV file, right? So here we have our CSV file, and the courses that this particular institute is offering are Hadoop, Java, Python, and yeah, so these are the courses that this particular institute is offering. So I'm going to categorize, or I'm going to partition these students based on their courses. So this is how I'll be partitioning them using this following code. So basically the table has all the columns, and I'm going to partition the table using course. So let's fire and enter and see the execution of this particular code. The partition has been done. Now all we have to do is try to load in our data. Before that, let's try to describe it. Let's try to see what are the columns present in our particular table student. So as you can see, the course column is present. Don't worry. The code looks that we have messed out course, but we did not mess the course column. It is present in the table. The only thing is that we have just partitioned it based on the course that we are going to offer. Now let's try to categorize the students based on their course. So you can do that by using the following code. We are going to load the data using the command load data local in path. So this particular folder, that is the student.csv, is in my local location. So that is home, Cloudera, desktop, student.csv, and I'm loading the data present in this particular location into the student, which is present in Hive right now. So I'm going to partition the student based on their course Hadoop. Now let's fire in this command and see the output. Yeah, now you can see some map reduce jobs taking place. Yeah, the data has been successfully loaded. Let's now refresh our Hive. You can refresh your Hive or Hue based on two methods. The first one is just clicking refresh button on the URL, or you can also select a manual refresh. This is the manual refresh, and there you go, it's done. You can see the new database, that is the Edureka student database that we have right now created. And inside that you can see the student table that we have created, and there you go, we have the file of students based on course Hadoop. Now we will try to add in few more students based on the course Java. For that, all you need to do is just replace the course name with Java. There you go. Here we had Hadoop course, and now here we have Java course. Just fire and enter and you can see the output. Followed by that, we also had another course, that is Python. So let's also execute a code for that. There you go, Python. So now we have uploaded student details into our Hive, and we have also partitioned using one of our data models, that is partition, into three categories that are based on Hadoop, Java, and Python. Now let's go back to our Hue and see if the three categories are done or not. Yeah, we need to refresh that. There you go, you have successfully refreshed. Still, there is no sign of Java and Python. Maybe a manual refresh could help. Yeah, the manual refresh has resulted in the two new files, which are Java and Python. So you have all the three partitions here, Hadoop, Java, and Python. Just enter them and you can see the student details. And now that we have understood partitioning, sorry, I forgot to mention, we have two types of partitioning, which are dynamic partitioning and static partitioning. So the static partitioning is in static or manual partitioning. It is required to pass the values of partition columns manually while loading the data into the table. Hence, the data file does not contain partition columns. You can see that we have sent the partition columns manually for Python, Java, and Hadoop. But when it comes to dynamic partitioning, you just need to do it once, and all the three files will be automatically configured and the files will be created. So now what is dynamic partitioning? So dynamic partitioning, the values of partition columns exist within the table. So it is not required to pass the values of partition columns manually. Now what is this? Don't worry, we shall execute the code based on dynamic partitioning and we shall understand this in a much better way. Now let's clear our screen. Now let's start fresh again. Let's try to create a new database for dynamic partitioning and let's start again fresh. So here we'll be creating a new database that is Edureka student 2. So earlier we created Edureka student and now we'll be testing our dynamic partitioning on our new database that is Edureka student 2. So there you go, the database has been successfully created. Now we shall use this particular database. Currently we were in Edureka student 1 database. Now we'll enter into student 2 database. So we'll use it now. Now we are in Edureka student 2. Now before we start up with dynamic partitioning, we have to set Hive execution to dynamic partition is equals to true, because by default the partitions that will be taking place in Hive will be static. So we need to convert that into dynamic partition by specifying this particular code. Now we are good to go with dynamic partitioning. Along with that, we need to execute another command which says partition mode would be non-strict. So by default, when you are partitioning using the static partition, the partition mode will be strict. So now you're specifying it to be non-strict. Now let's execute this. So there you go. We have executed the two required codes for that. Now let's create a new table. So the name of the table will be Edureka student, that is EDU-STUD, and this will have the same columns, which are the ID of the student, name of the student, course, age, etc. Now we will try to load in the data from our local path, that is home, cloud, or our desktop, student.csv into the table edu-stud. So the data has been successfully loaded and the size is 267 KB. Number of files is 1. Now comes the tough part. So here we are going to partition. So we will be partitioning the table based on the same thing, which is the course, and we will be separating the data using the comma. Now let's fire an enter. Now the table has been separated based on course, and now we will be loading the data to this particular table, which is the student part. So this particular table that we have created based on dynamic partitioning, and we are going to partition the data based on course. Now it's been created. So the student part table has been successfully created. Now the only part remaining is to load the data to this particular table. Now we will be writing a code. So using that code, the MapReduce will automatically segregate the data members or the students based on their courses. So the guys which are in Hadoop will be separated, guys in Java will be separated and loaded into different file, and similarly with Python. Now let's see how to do it using the code. So there you go. We are going to insert into student part, partition based on course, select ID, name, course, age from the table Edureka. So the data will be imported from the table what we have created here, that is Edureka student. So this particular location has the student.csv file. Now let's fire an enter and see if it's created or not. Fine. You can see some of the MapReduce jobs are getting executed. You can see we have 3 jobs. So first one is getting executed. We have 3 because one is for Hadoop, one is for Java, and one for Python. So this will take a little time. So this is the reason why I have chosen smaller CSV file, so to save time. When you take up the course from Edureka, then you can work on real-time data so that you get hands-on experience from real-time, and you can get yourself placed in some good companies with the experience what you gain from this particular course. So the stages are been successfully finished and the data has been loaded. Now let's see what are the data present in the particular table, student part. There you go. You have the output executed here. So these are the data members present in the partition student part. So these are the data members which are separated based on their courses. That is the partition based on their courses. That is Hadoop, Java, and Python. So now that we have understood dynamic partitioning and static partitioning, we shall move ahead into the last type of data model, which is bucketing. Once after we finish the bucketing, we shall enter into some query functionalities of Hive or query operations which can be performed in Hive. And followed by that, we will also learn some functions which are present in Hive and some of the other things like group by, order by, sort by. And finally, we shall wind up the session with joins which are available in Hive. For now, let's get continued with bucketing, the last type of data model present in Hive. So for that, let's again start fresh. We shall create a new database for that. Before that, let's go back to Hue and check if our partition has been made or not. Let's refresh. Also, let us make a manual refresh. So our database was Edureka student 2 database. And inside that, we have the table that is student part. And there you go. You can see the files which are based on the partition. So 22 is for a different course, 23 is for a different course, and 24 is for a different course. And this is the default partition which has all the data members. As we discussed earlier, now let's start with the last data model in Hive, that is bucket. Now we have created a new database that is Edureka bucket. Now we shall also create a new table for that. Before that, we need to start with this particular database so we can use the command use Edureka bucket. Now we are in Edureka bucket. Now let's create a new table. So the table name will be Edureka bucket, and it will be containing the ID name, salary, age of the employees. The table is created. Now let's try to load the data. So the data file that we will be using is the same one, that is the employee.csv. So the data has been successfully loaded into the location. Now comes to the major part, that is the bucketing part. So to start bucketing in Hive, we need to use the command set hive.info.bucketing is equals to true. So that's done. Now we will cluster or classify the data present in this particular file using this particular code. So we will be clustering based on the ID, and we will be categorizing them into 3 different buckets. So let's fire in this command and see if it happens. Yeah, that's successfully done. Now we will override the data using the following command. Now we'll be inserting data into this buckets that we have made, that is 3 buckets, and we will override the table using this particular code. There you go. You can see some MapReduce jobs to be taken care of now. So 1 mapper and reducers are 3 for now. So stage 1 is getting done. So we should be having 3 tasks basically. So let's see what's the output. Stage 1 is finished. The process is finished and data has been successfully inserted. Now let's go back to Hive and check if it's done or not. So before that, let's do a refresh. Now a manual refresh would be much better. There you go. We have our database here, which is Edureka bucket. And inside Edureka bucket, we have EMP bucket, and that's our data, employee.csv. There you go. Now let's move ahead and understand the basic operations we can perform in Hive. So for that, let's start fresh again. Let's create a new database. I'm creating a new database for each and every option or each and every operation that I'm performing in this particular tutorial, just to make things or keep things in a sorted manner. So as you can see here in our particular file system, I have separated each and everything, like I have sorted everything So for bucketing, I've got a separate database, and for partitioning, I've got a separate database, and for understanding how to create database and tables, I've got a separate database for that, just to keep things arranged and sorted. This looks in a much better way. So now let's discuss about the operations that we could perform in Hive. So I'm creating a new database again for this. So the database would be Hive query language. Now let's use this particular database. This creates a habit of learning things in a better way, or it's like a revision for the things what you have performed or learned so far. As you can see, the table has been successfully created. Now let's try to add in some data into this particular location. That is employee data. It's been successfully loaded. Now let's try to see what are the details present in this particular file. We can use in the command select star from the table Edureka employee. So there you go. These are the details or information present in the table Edureka employee. Now we shall see what are the functions that we can perform on this particular file. So since we discussed that the mathematical operations and logical operations can be performed on Hive, so let's try to perform an addition operation. So I'm selecting the column salary, and as we have seen here, the salaries are 25, 30, 40, 20,000 rupees for every employee. Now let me add in 5,000 more to each and every employee. So I'm adding the value 5,000 by using the addition operation. So let's enter. You can see we have added 5,000. So the first element was 25. Now it's 30. So similarly, all the other employees got 5,000 rupees hike all of a sudden. Now let's try to remove 1,000. So to do so, all you need to do is replace the addition operation with a subtraction operation, that is minus. Fire and enter, and there you go. Each and every employee lost 1,000. So the initial amount was 25,000. So removing 1,000 from that will result in 24. So this is considering the first initial values. So this is how it's working. Followed by that, let's also perform some logical operations. Let's clear the screen, and yeah, here I'm fetching for the employees who are having a salary equal to or greater than 25,000. So these are the employees which are having the salaries above or equal to 25,000. Similarly, let's execute another one which detects the employees with salaries less than 25,000. So we have got two employees which are having lower salaries, which are Amit and Chaitanya. Fine. So this is how you perform some operations in Hive. So now let's move ahead and understand the functions which you can perform on Hive. So in the same way, let's create a new database again, and let's use this particular database, that is Hive functions. Now let's create a table in this particular database. So the table is employee function and it's created. Now let's try to load in the data. Yeah, the data has been successfully loaded. And now let's see if the data is correctly loaded or not. Yeah, the data is loaded correctly. Now let's try to apply some functions in this particular data. So the first thing, or the first function I'm going to apply, would be a square root function, where I'll be finding out square root of the salaries of the employees. So there you go. The square root of 25,000 was 158 dot decimal numbers. So this is how you perform some basic functions on your data. Now let's try to find out the maximum salary. So yeah, the job is getting executed. You can see some MapReduce jobs here. I think the biggest salary would be from Sanjana. So the maximum salary is 40,000. So this is how it works. Since we are working on Cloudera and the system configuration is limited, the execution speed is a bit low. But if you're working in real time, then this process would take like a few seconds and it's done. There you go. You have the value 40,000 as shown here. So 40,000, the employee name is Sanjana, is the maximum salary. So that's what we got here. Now let's try to find out the minimum salary. So the minimum salary is 15,000, and who would that be? Yeah, it's Chaitanya with minimum salary 15,000. So that's how you do some operations in Hive. Let's execute some more operations such as converting the names of the employees to uppercase. So you can see the employee names are converted to uppercase here, and similarly let's try to convert to lowercase. So here you can see we have converted them to lowercase. So this is how you learn technology. You need to play with the technology. Then you'll come to know the advantages and disadvantages. So you can learn the possible ways where you can make things work out. This is how you do it. Now let's move ahead and understand group by function in Hive. So for that, we'll be creating a separate database that is group. Now we will use this particular database that is group. So we'll type in command use group semicolon. Now we'll create a table. So the table has been successfully created. Now we will load data into this particular table. Now we will use the new CSV file, which will be employee2.csv. Now we are using this particular table because we have an additional column in this particular table, which is the country column. Now, as discussed before, we will be grouping the employees based on country. Let's see our data first. So we have countries such as USA, India, UAE. So these are the three countries that we are having in our CSV file. So we will be categorizing the employees based on their countries. So this is the particular command that we will be using. So maybe I made an error while creating the table. I think I gave a wrong table name here. So let's drop our table. So by mistake, I gave different table that is employee order. So to drop a table, you just need to use the keyword drop and it's done. Yeah, the keyword table was missing. So you need to type in drop table and the table name and the table gets dropped. So we were supposed to create a different table that is employee group. So now let's create a new table that is employee group. Employee group has been created. Now let's try to add in data into the employee group. So we have used employee 2 here because the employee 2 has another column which is based on country. So the countries that we are having here are India, USA, and UAE. So we will be using the group by function here, and we will categorize the employees based on their countries. So there you go. You can see some MapReduce jobs getting executed. Yeah, there you go. We have categorized the employees based on their countries, that is India, UAE, and USA, and the sum of the salary. So the guys working in India and their summation of the salary is 90,000, and similarly UAE is nearly 1,05,000 and USA is 80,000. Now let's also execute a different command based on group by. So here we'll be using group by function, and we will categorize based on the country as well as the summation of the salary, which is greater than or equals to 15,000. So it's similar to the previous command. So you can see the data got executed and we got the same output. Now let's move ahead and understand order by and sort by methods. So for that, we'll create a new database orders. Now we'll use orders. Now let's create a new table again. So the new table is employee order and the table got created. Now let's load the data into this particular table. By now, I think you have some good practice of how to create a database, how to create a table, and how to load data into that particular table. So the data got loaded, and now we are going to order the data present in this particular table based on the descending order of their salary. So you're seeing some MapReduce jobs going ahead. So here we'll see the employees ordered based on their salaries in descending order. So the highest salary will be at the first place and the lowest salary will be at the last place. Yeah. So we have Sanjana at the first position with 40,000 as the highest salary, and she's working for UAE. And we have Chaitanya with lowest salary, 15,000, working for India. Now, let us also execute another command based on sort by. So first we try to execute a command based on order by. Now let's see the same output using sort by. So basically both work in the same way. So there you go. We have sorted the records based on descending order of salary. Now that we have learned what are the various operations that can be performed in Hive, that are the arithmetic operations, logical operations, and also some of the functions such as maximum, minimum, group by, order by, sort by. So these are the various operations and functions that you can perform in Hive. Now let's move ahead into the last type of operations that can be performed in Hive. Those are the joins. So for that, let's again create a new database. So here I'll be creating a new database that is Edureka join, and followed by that, let's use this particular database. Now for that, we need to use the keyword use, and there you go. We are in Edureka join. Now let's create a new table for that. So the table will be emp join. Here you can see that I forgot to mention semicolon. So now the table got created. Now we shall load the data into this particular table. So now I've created the first table, that is employee table, and I'm loading the employee data into this particular table. Now to perform join operations, we always need two tables. So in this particular database Edureka join, I've already created the first table, that is employee join. Now let's create second table, that is the department table, which will be present in the same database. So this particular table is a department table, which will be having the entities that are department ID and department name. Now let's load the data of department into this particular table. So the data has been loaded. So you can see the employee2.csv had the columns ID, name, salary, age, and country. And similarly, the department.csv has the entities which are department ID and department name. So the department IDs are present here and the names are development, testing, product, relationship, and admin and IT support. Now we have created both the tables and we have loaded the data also. Now we have 4 different joins available in Hive. They are inner joint, left outer joint, right outer joint, and full outer joint. Now let's perform the first type of join, which is the inner joint. So in inner joint, we are going to select the employee name and employee department. And based on the employee ID and department ID, we are going to perform the join operation. That is the first join, inner joint. So you can see some jobs getting executed. So the map reduce task successfully completed. So the first set of join has been successfully finished and the output has been generated. Now let's try out the second type of join, that is the left outer join. So the only difference is that we are using the keyword left outer join. Now you can see one of the job got started. So you can see the output has been generated as well of the left outer join. Now let's move ahead and understand right outer joint. So for right outer joint, you need to use the keyword right outer join. Fire in the command and you can see the jobs getting executed. So you can see the output of right outer joint has been successfully executed or displayed. Now let's type in the last join operation, that is full outer join. So here I'm using the keyword full outer join. Fire in the command and you can see it's getting executed. So the output for full outer joint has been displayed here. So this is how the join operations are executed in Hive. So we have learned how to create database, how to create table, how to load data, and the various data models present in Hive, that are the tables, databases, partitions, bucketing. And after that, we have also understood various operations that are the arithmetic operations, logical operations, and functions that can be performed in Hive, such as square root and summation, minimum, maximum. And after that, other operations such as group by, sort by, order by, and also the joins that are possible in Hive, which are inner join, left outer, right outer, and full outer. So each and every operation that could be possibly executed in Hive have been displayed in this particular tutorial, and everything is sorted here in the base of databases, and you can get all the details about this And you'll also get the code that I have used in the description box below, and you can try it out. And also, if you're looking for an online certification and training based on big data Hadoop, then you can check out the link in the description box below. And during the training, you'll get to have real-time hands-on experience with real-time data. You'll learn a lot of things in the training. And so far, so good. Now we shall also discuss some of the limitations of Hive. So Apache Hive limitations. So Hive is not capable of handling real-time data. Hive is capable of batch processing. If you have to work with real-time data, then you have to go with real-time tools such as Spark and Kafka. So it's like Hive will actually take in the data. For example, imagine you're working on Twitter and you have 1 lakh comments on a particular post. So if you had to process those 1 lakh comments, you'll have to first load all those comments into Hive. Then you need to process it. So while you're loading the data from Twitter to Hive, you may also get a few more comments that you will be missed out. So it's not preferable for real time. Hive is preferable for only batch mode processing. So followed by that, it is not designed for online transaction processing. So online transaction processing is something which only works in real time. So Hive cannot support real time processing. So last but not the least, Hive queries contain high latency. Yeah, Hive queries take a longer time to process. As you've seen, I've taken a smaller CSV file and the time consumed to process such a small CSV file was taking so long. So yeah, Hive queries contain high latency. So these are the few important noticeable limitations of Hive. So with this, we have come to an end of this particular tutorial. If you have any queries regarding this tutorial, or if you require code that we have executed in this particular tutorial, then you can write us down in the comment section below and we will respond to you as soon as possible. So till then, wish you all a very happy learning and thank you.